Assalamualaikum and a very good day to everyone. We are from Motu and this is our case study project mission 3 of the Ericsson Educate Dash Traveler game. Introduction. As time goes on and technology advances, we can see transition from analog information signal into digital form, where the digital signal transmission requires a signal which is in the form of binary or pulse signals in discrete form. The pulse modulation can be categorized into 4 types: pulse amplitude modulation, pulse width modulation, pulse position modulation, and pulse code modulation. What is sampling? Sampling is the process to convert the analog signal into discrete form by obtaining samples of the information signals. Meanwhile, sampling theorem or Nyquist theorem states that the sampling frequency should be greater than or equal to twice the maximum frequency signal. Sampling process must follow sampling theorem to overcome duplication and loss of information.
Hello, my name is Jasmine. So now I would like to explain about quantization. So what is quantization? So quantization is a fundamental concept in the digital signal processing, which involves the conversion of continuous signal into digital signals. The process of quantization involves dividing the range of possible values of a signal into a finite number of levels, which are then represented by a digital code. There are basically two types of quantization: uniform and non-uniform. Uniform quantization has an equal spacing between the quantization level. Under the graph here, shown that mid-thread type uniform quantization and mid-rise type uniform quantization. As you can see, the intervals between each of them are equal. And for non-uniform quantization has a non-equal spacing between the quantization level. So under the graph below here, we can see that the intervals between each another are non-uniform.
Good day everyone, I'm LEEZ. Now I will continue for quantization. There are some terms that commonly used in quantization. Firstly, quantization level, L, which is used to represent each level. The formula of quantization level will be 2 power of n, where n is the number of bits. Then, quantization interval delta V is the magnitude difference between quantization level, and the formula is peak-to-peak voltage divided by quantization level. Third one is quantization value that refers to middle voltage for each quantized level. There are two quantization values, VKL, which is the lowest level of quantized voltage, and VKH is the highest level of quantized voltage. The difference between quantized value and the real value will be quantization error. So, the quantization value is the difference between maximum and minimum value of voltage, and the quantization error delta V over 2. Not only that, bit depth is the number of bits of information in each sample. The higher the bit depth, the lower the quantization noise.
Hi, my name is Robin. Now I will explain about the multiplexing of signals. The multiplexing in telecommunications means that it is a process of transmitting two or more signals simultaneously over a shared medium. Its objective is to increase the capacity of a transmission channel. There are three types of methods for this multiplexing. First one is frequency division multiplexing, the second one is time division multiplexing, and the third one is space division multiplexing. The first one is frequency division multiplexing, FDM. It uses a different carrier's frequency for each channel. The second one is TDM, time division multiplexing. It uses a different time slot for each users of channel, but with the same frequency. The last one is space division multiplexing, SDM. It uses several independent spatial channels to increase the capacity for optical communicational channels.
Assalamualaikum and hello everyone. My name is SALEHA. So what are the advantages of PCM? Firstly, PCM has high quality signal representation. This ensures accurate transmission and reproduction of the original signal. Secondly, compatibility with digital systems. PCM is well suited for integration into digital systems and networks, making it compatible with various digital communication technologies. Thirdly is high signal to noise ratio. PCM are less susceptible to noise and interference during transmission compared to analog signals. This results in a higher signal to noise ratio, improving the overall quality of the communication. Let's move forward to advantages of multiplexing. Firstly is cost efficiency. Multiplexing helps reduce the overall cost of infrastructure. It minimizes the need for additional transmission lines or channels for each individual signal. Next is flexibility. Multiplexing provides flexibility in combining different types of signals such as voice and data over the same transmission medium. And the last one is optimized bandwidth utilization. The efficient use of bandwidth is crucial in telecommunications, where optimizing the use of available resources is essential. The advancements related to PCM in the communication field are enhanced compression algorithms, real-time processing, and higher bit resolutions. Meanwhile, the advancements related to multiplexing in the communication field are software-defined networking, wavelength division multiplexing, and coherent optical communication. So the advancement has impact and benefits to society. It is improved connectivity which enable people to communicate more effectively across various platforms. The efficient use of bandwidth and network resources leads to cost savings and environmentally sustainable communication infrastructure. It is also enhanced user experience in applications such as online gaming, video conferencing, and multimedia streaming. In conclusion, multiplexing and PCM provide a comprehensive understanding of basic principles in signal processing and communication. These ideas serve as the foundation for a wide range of systems and technologies that facilitate the efficient and successful transmission of information, advancing the disciplines of telecommunications and related ones.